Today we're going to be multiplying decimals as fractions and then multiplying them also as decimals. So we'll use a model to visualize this process and also talk about how that relates to any other understandings of place value. So the first problem is 1/10 times 1/10. So I want to show that in opposite directions on a model. So if I look at my place value chart, if I want to record 1/10 vertically, it would look like this. I would shade in 1/10 of the model. Since I'm multiplying my 1/10, I'm going to also shade in 1/10 horizontally in the opposite direction. The portion that overlaps is my answer to the multiplication problem. Since that section right there overlaps, that would be 1/100th, which would be my answer. Let's look at that, what that looks like as far as place value. So if I have 1/10 times 1/10, 1 times 1 is 1, and I know if I multiply a 10th times a 10th, I would get 100th. So my answer would be 1/100th. Well, let's look at that on the algorithm in decimal form. 1/10 times 1/10. 1 times 1 is 1. I'm going to count the number of decimal spaces in my problem, and then I'm going to put an equivalent number in my answer. So I have 2 decimal spaces in my problem, and I should have 2 decimal spaces in my answer. And I know because I have a blank space, I'm going to fill that in with a 0. So you can see each way I write the problem, whether I write it as a fraction, whether I write it as a base 10 numeral, or whether I write it as a decimal, I always end up with 1/10. It's just different ways of representing the exact same problem. We'll look at another couple that are a little bit more tricky. So this one shows 4/10 times 3/10. So again, I'm going to shade in opposite directions to represent the 4/10 and then the 3/10. So I want to show 4/10 horizontal or vertically. So there's my 4/10, and then I want to show 3/10 horizontally. So if I look and count the section that's overlapping, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 that are overlapping out of the whole 100 square. So I have 12 hundredths when I think of a fraction answer. Obviously I would need to reduce that, but because we're going to connect it to decimals, I'm not going to reduce it today, but generally we would go ahead and reduce that. So if I want to look at it as a base 10 numeral, I would have 4/10 times 4/10. Oh, I'm sorry, 3/10. 4 times 3 is 12. A tenth times a tenth is 100th. So I have 12 hundredths. And we'll also look at the standard algorithm when we multiply them as decimals. So 4/10 times 3/10. 4 times 3 is 12. I have 1 decimal there, 2 there, 1, 2 in my answer. I end up with 12 hundredths. So if you look at each way, I always end up with 12 hundredths. It's just a different way of representing that. Okay, this particular problem is a little bit more challenging. This one is more challenging because we can see, first of all, I have a fraction and a decimal mixed, so it makes it a little bit more tricky. It gets also tricky because I can see I go over 1 whole. So let's just convert them both to fractions. I think that'll help us first. So if I have 1 and 7/10, it would look like that. So I'm going to start off with this 6/10, and I'm actually going to write this one horizontally, and I'm going to carry it over to both squares so I can see what 6/10 would look like on both squares. So 1, 2, 3, 4, 5, 6, and I'm going to carry this across both squares. It's a little harder, I think, to understand the pictures when you get to these larger numbers, which is why our algorithm comes into handy. You'll probably be more inclined to use the algorithm to understand these problems. So now I have 1 whole and 7/10. I'm going to shade that the opposite direction. So this whole section would be shaded. There's my 1 whole. And then I have 7/10. 1, 2, 3, 4, 5, 6, 7. So if I look here at the overlap, I have 60. Over here at the overlap, I have 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6. 6 times 7 is 42. So if I add those two together, you get 102. So I have 102 hundredths. If I wanted to convert that to a mixed number, it would be 1 and 2 hundredths. Let's look at that if I were to multiply it using base 10 numerals and also with the algorithm. So I have 6/10 times, a little easier if you put your bigger number on top. So we'll say 17/10 times 6/10. 6 times 7 is 42. 6 times 1 is 6, plus 4 more is 10. So I have 102 tenths times tenths is hundredths. And then if I just look at the algorithm, I have 17/10 times 6/10. 6 times 7 is 42. 6 times 1 is 6, plus 4 more is 10. I have 2 decimals in my problem, so I should have 1, 2 in my answer. And again, I end up with 1 and 2 hundredths. 102 hundredths we know would be the same as 1 and 2 hundredths. Does that?